So what is going on? Why everybody is here? Did I say something last time? Oh, because last time I didn't do the lecture, so you missed me. Okay, good. I miss you too. I forgot about the attendance sheet. It will be ready the next lecture in an hour. Okay. So last time we were talking about spelling correction and noisy channel model, and if we do some very fast review of it, okay. The previously we learned how to measure the distance between two words, okay, whether those words are real words or what? Do you guys hear me, online people? Are there any online people? Yeah, I have, no, 0 people?
All people in the class.
Everybody's in the class, really? Can somebody check if this meeting is available? Sometimes it is not available. Is it available? Can you?
The meeting is available.
Yeah. Can you log in? Can you sign in? Yeah. Okay then. Maybe I should. No. Well, okay. Everybody's here. Okay. Good. Thank you. So we said that, okay, measuring the difference, the distance between two words, is a tool that we can use for spelling correction, but we don't know if we need a spelling correction for that word, right? So maybe we did this. Maybe we looked at the difference between non-word errors, like this. Is it going to be giraffe or graph or grape or whatever? Okay. And there is the other thing, okay? Some real word errors, okay? Like instead of 3, I write there, okay? Instead of piece, I write piece. Instead of 2, I write 2. Like that, okay? So these are the tougher spelling errors that we like to address. And we looked at these statistics, and I'm going to skip those. Okay, and this noisy channel model, invented again in 1950s, 60s. It says that, okay, whatever you transmit over a channel, whether it's a wireless channel or the cable channel or a medium that you put the original word at the end of, you get the noisy words. Okay, how can we guess the error and how can we fix it? We can use the same idea. Okay, I observe these signals, whether they are words or not. Okay, what are the possibility that original words are these? Okay, so if I have such a model of the channel, then I can calculate this. That's what we are going to do. And as always, we cannot calculate this very easily in this way. Using the bias rule, we can do that. Okay, what is the probability of seeing these words? And given these words, what is the probability that I am outputting these words? This is much. I know, okay, we have already model for this one. We have the language model, right? N-grams. Okay. We have the N-grams model for that one, or the neural language model. For this one, it is relatively easy to calculate it because given a word, okay, for example, there, I can keep statistics of how people write this word. Some people write this word as these. In fact, it looks like these. Okay, this is word R, and this is not O, this is E. Okay, so some people write this as these, or sometimes this, that, sometimes 3, etc. So I know I can keep that kind of statistics between the meaningful words. Also, I can keep the statistics about most frequently mistyped letters, like instead of E, I usually type 3. You know this, right? Instead of this, you know the positions of these. You know the position of these two letters, right? I mean, E and 3 just, for some reason, instead of E, I keep pressing this 3. And it looks like actually E. So I can calculate this easily, easier than that one. So this will give me kind of a model for the noisy model for this channel. Okay, what is my channel? My brain, my fingers, the keyboard, and etc. Okay, it won't be a perfect channel, but it will be better than that. So people have used this idea, and that was the thing. So let me skip all this part because we talked about this, and I think at the end we came about, okay, so this was a nice example. If somebody typed, okay, if somebody typed this word, yeah, if somebody typed this word across, okay, I think this across is not in the dictionary. That's a not meaningful word. Okay, it could have been any of these, right? Any of these. These are all in the dictionary. These are the correct words. We don't know, and you might say that choose the one that has the shortest edit distance. But there are many words with the same edit distance. So what are we gonna do? But our model says more than that. Okay, our model says that what is the probability of, okay, that word happening in a sentence. Okay, it looks like this across happens a lot. Okay, what is the distance between across and across? It is just a single where is across, just a simple substitution. Okay, so most probably if you don't look at the context of the word, most probably it is this one. That's how we calculate stuff in here. So by looking at just simple edit distance, most of the time will not be enough. It is better than nothing, but it will not be enough. Okay, so edit probability, we talked about these. We talked about these matrices. Okay, and these are the letter errors depending on what kind of error you made. Okay, it came from the table. I know the word probability. If I multiply both of them, it looks like if I multiply the word frequency with the model of the keyboard and human brain, etc., it looks like the highest probability, say, cross again, 2.7 times 10 to the power 9, or divided by 10 to the power 9. Very small probability, but higher than the others. Okay, so we looked at those, and I think the place that we stopped is, okay, real word spelling correction. Okay, usually the most problematic ones are these. 40% of the, for English, spelling errors are real words. Okay, I say the design and construction, this is not an and, this is a. Okay, design a. Okay, can they have him? Okay, can they leave him? Yeah, leave him. See, have is leave and leave, they are all real words. Okay, so spell checker, just if you do the spell checker, it will not give you anything. Okay, it will not give you anything. So what are we gonna do with this kind of problems? Was conducted mainly by John Black, but I wrote BB is a real word. Okay, so that's the statistics. Those are the real problems. So what are we gonna do? We will generate for each word. We are going to generate the candidate set. Okay, and the candidate set includes the word itself. Okay, if I type the, maybe I really meant the, right? Okay, and single related edits that are in English words, and the words that are Homophones. What was the homophone?
Like piece, one piece, and world piece.
Yeah, one piece and word piece. For English, we have many of those, right? I mean, for many words, we write this differently, but we pronounce them the same. So they will be coming to the picture. In Turkish, we have, of course, we have similar problems, but it is not exactly the same. And choose the best candidate using the noisy channel model or task-specific classifier. So candidates are these, including the word itself, and run the noisy channel, something like that. But the thing is this: with the two, I can have any of these. So there might be maybe 10 alternatives for the two. Okay. With the of, again, the same thing. So if I have 10 words in a sentence, and for each word, if there are 5 possibilities, that makes 5 to the 10 different paths, right? The 5 to the 10 is a very, if you don't know about it by now, what does this mean?
What does it say?
So it says we keep calling if it is successful something. Oh, okay. It says that you are doing a meeting by yourself. Okay, but I am not doing it just for the fun of it. I am recording it, right? I am recording myself, so I don't have to feel guilty about it. Okay, good. So this many paths, checking this many paths is not possible. That would be too much waste of time whenever you write something. Okay, what would be a better way of coming up with an approximation? Okay, we said that maybe, okay, 1 error per sentence. Take the sentence. Okay, take the sentence. You say that, okay, people don't make, okay, mistakes one after the other. Usually, I mean, for me, the average is maybe 1 spelling error every 5 words, okay? And 60% of those words will be non-words. Seeing the numbers is easy. Real words are the difficult one. Maybe I can assume that every 10 words, I will make a real word spelling mistake, okay? So that means what? Assumption is this: 1 error per sentence. So I will say that I am going to run this. I am going to say 2 of the, okay, all of them are correctly spelled, okay, real words. Maybe I will just test these possibilities and, okay, this one, and go that way. This one, these are the paths. So there are a total of 4 paths coming from the 2. I tested the probabilities, all of them, run through my model, and I checked them. Okay, I kept them somewhere. I do the same thing with of, okay, and 3 possibilities came from here. Okay, but these are not multiplying with each other. 4 possibilities here, 3 possibilities here, 4 possibilities. So it will be, instead of 5 to the power 10, it will be 5 plus 5 plus 5 plus 5 plus 5, total of 5 times 5, 25 possibilities. 25 is, believe me, much smaller than 5 to the 10. Okay? Yeah.
How about doing it dynamically? So we look at which one of those, the two, thou, and two, can come at the beginning of the sentence. Then after we decide one of those words, we go to the next one and see which one of those most likely to come after the choose.
Well, that would make another heuristic, okay? You because you are not checking all the possibilities. I mean, if you are trying to run some kind of a dynamic programming algorithm, this is what happened before me. Depending on this, what would happen? The thing is that the mistakes that you can do with this and this are independent. Okay, I cannot keep all the possibilities of mistakes in a table smaller than 5 to the 10. Okay, so I have to keep these possibilities and these and these. Previously, what I did was, okay, remember the dynamic programming table for the minimum edit distance.
Yeah.
Whenever I try to check one box, try to put some number in the box, I used to say that, okay, this is what could have happened before me. Just three possibilities. Choose one of them, and I continued this way. That was a very special case, because that was one-dimensional problem. This is not actually. This is every time you can go any of these 5 places. Okay. If you assume that the mistakes are kind of related and this one is related, then it can happen that way. Yeah. So I mean, I'm not saying that your idea is a bad idea, but you are not going to address this exponential complexity problem 5 to the 10. Okay. So so this is one thing that I like you to have from this course actually. Can I apply dynamic programming to this problem? So your thinking is very good, but unfortunately, dynamic programming will not work here. Okay, principle of optimality will not work. It will not work. Okay, because after seeing all these sentences, words, at the end of the sentence, I will put a word, and that word will change the meaning of the whole sentence. Okay, that can happen. Good. So we do this simplification, 1 error per sentence. Again, we are not solving the problem optimally, but it is better than not doing anything. Okay. Getting the probabilities. Okay, what is the probability of this sentence? Okay, this sentence, that means what is the probability of word 1 ... word n. We already have our statistical language model, unigrams, bigrams, and etc. And there is this channel model. It is almost the same thing, so we are not going to talk about it. This one is a very interesting probability. Just because you are saying the means that the user types the or wants to type the. Okay, just because somebody says I am guilty, okay, that's one of the basic rules in criminal justice, right? If somebody says that I killed this guy, do you believe him? No, you don't. Okay? You need evidence. Just because somebody says that I did this, I have stolen this money, you don't believe them. Okay? That's a very good observation. It's a very important clue, but you cannot judge. Okay, you cannot. If somebody comes to you and says that I am guilty, I killed this guy, you don't put him in jail because he might be lying, right? And people have many reasons to lie about killing somebody or something. It's something like that, right? I type the and I mean the. There is a probability, very high probability, but it is not 1.0. Okay, because sometimes when I type, maybe I wanted to type this one, right? Okay, maybe I wanted to type this one, I don't know. Okay, so how am I going to calculate this one? Of course, it depends on the application, the user, etc. If I am making 1 error every 10 words, and in each of those 10 words are spelled correctly in dictionary, then one of them must be wrong if I am doing this all the time. So calculating this one needs some statistics again. Okay.
Do we need to correct this kind of errors?
Say that again?
Do we need to correct this kind of errors?
Sure, yeah.
Because
Well, that would be very useful for the user, right?
but I think it's not the context of the natural language processing.
Well, it is exactly the context of the natural language processing, because natural language processing is a important field of AI. In this field, we deal with this kind of crazy problems. I mean, do we have to correct this one?
Yes.
The study was conducted mainly by John Black, and in some case it might make sense too, but no, I mean, this must be by. And if your word processor somehow makes a suggestion on this, did you mean by? That would be very, very useful.
I mean lying errors, not
I didn't say the typers are lying. I gave that example for the criminal justice system already. Okay. If you are a policeman, if you are the judge, if you are the somebody, okay, you don't take somebody's word as truth. Okay. You look for the evidence. This is typed correctly, B, right? This is in the dictionary. But if I look around, other than this guy, all the others are saying that this must be by. That's what I am saying.
So
Okay.
we can use something like anagrams. Am I right? We will look the similar words to be or by or being, and we try to look at anagram similarity of the.
That's what I said actually, kind of. Okay. This is the. What did we say? The algorithm is this. For each word, come up with a candidate words. Okay. For B itself is a candidate word. By is another candidate word. Okay. I cannot come up with another word. So many candidate words, even for the correctly typed words, and run it through your algorithm. What is our algorithm? Our algorithm is, what is the algorithm? Okay. If I see, let's go back to the original stuff. Okay. If I assume everything is right, yeah. I observed this sentence. It will be completed by John Black, or if it will be completed by John Black. Okay? Those are my observations. Given these observations, what is the probability that it will be completed by John Black? This is what I am calculating, okay? So it depends on what your model is. It could be noisy channel model, or it could be n-gram model. For this one, we have the n-gram model, yeah. For this one, how am I going to do that? That's what we are talking about, okay? So this is your language model, and language models could be n-gram models, statistical models, noisy channel models, or neural models. There is a classifier, or there is a regression model. It takes a sentence and it assigns a probability to it. Okay. However you it, I don't care. You give me this, and I am going to. Okay. So we will keep doing this all the time. What is the probability of really having this sentence, and what are the probabilities that if I type this word, it turns out to be this word, the observed word. Okay. So again, this is like causative probability. Just because my thermometer says that 21.2 doesn't mean that the temperature outside is 21.2, right? So there are models like this. Given 21.2, what is the probability that temperature is less than 20? Okay. So how am I going to calculate this? Okay, if I am the one who built this thermometer, okay, then I can calculate this, or if I have the statistics. Again, the same thing. If somebody types B, what is the probability of? Okay, yes. Again, these will come from the statistics of typing the words. Okay, go back, and let's do this. How do I calculate the probability of the? Again, you keep the statistic. It is very, very difficult to model the human mind. We do it that way. And this guy, Peter Norvig's Dewey example, remember that one? If I observed Theo, and what is the intention? It is the or Theo, or, by the way, this is a real English word, tau or true, or I don't know what these are, very rare words, okay? And this is the probability of, again, see this one? I assume that if somebody types Theo, the real word is, if somebody types Theo and real word is Theo, it is 95%. looking at the statistics of how the words work. But this word is very rarely used. If you multiply these two, this is what you get. Okay? But if somebody typed this, if they meant this one, okay, seeing this word instead of this one has a very low probability, but this word happens so much, so it is final probability so high. Okay, so that's why we choose this one. Again, but I did not look at the other words in the sentence. If I look at the other words in the sentence, if I use the Engram modeling, and by doing this, what is my probability of this sentence? If in that case the probability comes back very low, maybe I'm going to choose this one. Okay? Good. So we talked about the real world correction stuff. State-of-the-art systems, okay. What does the word do? Word usually doesn't give you suggestions for the English word, right? If you type something correct, it doesn't do any objection. It doesn't say that maybe you meant buy or maybe you meant be, right? It doesn't say that. But there are some smart editors that try to do it. Okay, if they are very confident, they do it automatically. And sometimes people don't like it. For example, Word is saying that any word that starts at that comes at the beginning of the sentence, Word automatically capitalizes that word, right? Yeah, exactly. None of your business. I'm sure there is a way to make it. Especially in Turkish, when you say İkinci Dünya, of course, İkinci Dünya Savaşı, right? It just makes this just capital D, right? I hate it. It is autocorrect, so people don't like autocorrect all the time. But if the system is very sure about it, then why not? It works very well for English, not for Turkish, but very well for English. So those people, whoever did the Turkish word, they didn't translate all the rules from English to Turkish. In Turkish, we have many, okay, small case letters after the period, right? So they don't know about it, obviously. And if I am sure, I correct it. If I am not sure, I give a last, okay? And if I am less confident, I don't make any, give a lot of words, choose one of them, okay? If I am unconfident, I say that there is something wrong with this word, but I don't know what it is, without giving any suggestions, okay? So these are some ACI issues, and there is no single solution for those, okay? Remember this one? We said that we measure the probability of making the error and probability of that sentence, and sometimes we don't trust our model much. That's why we put a lambda at the top, and lambda depends on the person, depends on the development set. So sometimes from time to time we can play with this model too. In English, this problem is more of a problem because most of the time I don't know how to spell a word that I'm writing, okay? And for example, the words that start with K and N, such as this one, or ni, right? So you don't pronounce K at the beginning, right? You just say no, ni, etc. Okay, so take this into account. If a word starts with KN, okay, maybe it is the distance to the correct letter N should be just N. I don't know. The same thing again. If a word starts with a G, N. So tell me something that starts with G N.
No.
What?
No.
Who?
No. No. O-N-E.
First window manager.
But that's not a word.
Yeah, that's a word.
No, that's not a word. Is that a word?
That's small.
Oh yeah, that's
Dwarf.
that's a mammal. Okay.
That's a mammal. It's a small mythical creature.
Yes,
No.
dwarf like.
Isn't that a mammal?
Anyway.
Alright.
Okay, it's a made-up word. I don't know. I mean, so you don't spell the word in a regular way. This P and pneumonia, right? Pneumonia.
Yeah.
You don't say it. Again, right, wrong, right, wrong. What else? WR. You get the
Rest.
idea, right? You drop the first letter,
Rest.
okay? And the C and K, etc. They might be changed because they pronounce using their own rules. Okay, so you can change your edit distance depending on the spelling of the words. Okay, so I think one of the editors are doing this. I don't know which one. Okay, so somebody say that remember PH, Philippines or what?
Phosphorus.
El- yeah, elephant. Yeah, it is not PH. It is F, right? Okay, so keep the pronunciation rules in picture for English. It will be that. Okay, so I guess nearby keys again. It will be in our model. And sometimes we do this classify based stuff. Okay, machine learning stuff that learns. Okay, that learns how to correct this stuff. I am always confused between this whether and whether. Okay, do you know how to differentiate between them? This is about what is happening with the air,
Yeah.
rain, and this is,
It's WH question.
yeah, WH. Yeah, it is like who, where, which, and this is one of them, WH. Okay, but which one are you using? Okay, it depends on whether this is right or wrong, and it depends on whether it's going to rain or not. It depends on whether how it's going to be. Okay, so sometimes it is very confusing between them because whether and whether can happen in the same sentence too. So run a classifier. Okay, classifier will have a okay. Go to Wikipedia. Okay, find this word whether and whether, thousands of each of them, and train a SVM classifier for that word. And whenever you see that word, okay, run this classifier to see which one it is, and suggest the typer that did you mean this one other than that one if you are confident. So are we going to do this all kinds of words? Well, it is not that easy, but we can find maybe a good way of coming up with a better solution. Okay, so that's it about the spelling correction. So this spelling correction may be the first real application that uses our language model. Remember the language model that we said that given this sentence, W1 to WN. Okay, so this model, we can use this model to do the spelling correction. Okay, and we have seen a few cases. Good. Any questions so far? Okay. Remember that. Remember the first formula that I gave you at the beginning of this noisy channel thing. Okay. This one was invented way before NLP people started using it. But this problem you are going to see in a lot of places. Okay?
It's very popular in statistics.
What?
Statistics.
Well, it's not statistics, no. Statistics is about how to calculate maybe P. Okay? It is one way of calculating P. This is about, these are my observations. The real thing does not mean the observations, okay? The real thing might be something else. What is the probability of real thing being this? Okay? And usually we don't calculate this probability or the estimation using this formula like directly. We try to convert it to this case because this is much easier compared to this one. Much easier to calculate because this one has the model for the real world. Maybe it's a language model for this case, or maybe a model for the, for example, remember the temperatures? Okay. So what is the probability of having a temperature like 100 degrees? Nobody has seen 100 degrees in anywhere, any part of the world, right?
Unless you're in America.
What that?
Unless you're in America.
Well, I am talking about Celsius. Yeah. Nobody. I hope anybody seen 100 degrees. Not in Earth. Maybe in Mercury. Yeah. So I mean, there is always a model for things that's happening, and there must be a model, something like that. Given these words, what is the probability that I am observing this in the real world? Okay. So this is very important, and we applied it to the NLP, and you can apply it to pixels, for example, pictures. Okay. I am observing these pixels. What is the probability that a man is causing these pixels in the picture, right? So if you have a good model, then you can use this to detect persons on the street, etc. Okay, so let me start with the new chapter if I don't have any questions. Are there any questions? Okay, and we are going to, by the way, we are going to use this model again when we do the part of speech tagging and the parsing. Okay, and our model doesn't have to be the language statistical model.
What will we use it again?
Part of speech tagging
Part of speech.
or parsing, and part of speech is the next. You will understand what that is. Okay, let's start part of speech. Okay, so last year our midterm, what is this, April 19? Well, I don't know what April. I am not teaching this lecture. I don't know where this come from. Oh, maybe. Should I? Okay, don't read this. Your midterm exam already happened. Okay. Okay. So part of speech tagging. This is what we are going to do. First, let's look at the problem. What is parts of speech? We don't have exactly the same problem defined in Turkish literature or Turkish language studies, but we are kind of similar stuff. Given a sentence, every word in that sentence has some kind of a function, right? So we say that this is the verb, the main verb of the sentence, okay? And these are the nouns, and these are the prepositions, adverbs and pronouns, and etc. So we like to assign some kind of a label for each word in a given sentence, like this one. Let's say I have this stupid sentence: the koala put the keys on the table. Okay, so this. Okay, this is a mammal, right?
Yes.
Okay. So this koala is noun definitely. Put is verb, determiner, noun, preposition, determiner, noun, and this is determiner too. Okay. So I assign one class for each word. Okay. These are the part of speech classes or part of speech tags. That's the problem of part of speech tagging. So isn't this as simple as looking at the? Isn't this as simple as looking at the dictionary? Okay, let me go to the Webster dictionary. Okay, Webster and put. Okay, so go to the Webster dictionary, look at the meaning of put, and it's going to tell me this is a word or noun. Okay, so it's a transitive verb. Okay, so it's a verb. What is wrong? I mean, just look at the dictionary, and put is a verb. But if you continue, okay, These are the 8 different meanings of put as a verb and a transitive verb. Okay, what is a transitive verb? What is intransitive verb? Transitive means that transitive means what?
Something that takes object.
Yeah, it takes an object. So put the book on the table. Okay, it needs a object like that. And intransitive verbs, okay, are different. And these are the verbs that maybe you can just say verbs, but if I continue, put has a noun meaning too. Okay, depending on the context. Put a throw made with an overhand pushing motion. The act or an instance of putting the shot. Okay, that's one sense. And put could be an adjective too. Okay, being in place. Stay put until I call. Okay, and are there any other part of speech tags for put? I am not sure, but I mean, if you look at it hard, you are going to find it. Usually, more popular the word, more frequently used the word, more number of part of speech tags that can happen. Okay, so this is a correctly assigned sequence of tags for this simple sentence. The usually is determiner. Call, I am sure, it has an adjective meaning. It has some. I don't know. I don't think that it's a verb. But put has 4 different alternatives. Keys. I am sure key it can be used as a verb too.
Yes. Key in
Okay.
the car.
Yeah, exactly. And for the others too. So it is like remember that problem of 5 to the 10. So everybody has more than one alternative, and we like to find the exact solution for this one. Part of speech tagging is something like that. Okay, part of speech tagging is something like that. So you understand what the part of speech tagging. So the second question is, why are we doing this? Other than because I am making you to do it. Why are we doing this? Why part of speech tagging is an NLP problem?
Machine translation maybe. For
Yeah, exactly. The machine translation, right? If we do the machine translation, am I going to use this put as a verb or noun, right? If it is noun, then it has a different corresponding word in Turkish. If it is a verb, then it is different, right? It is very important. For example, play. Okay. I play soccer is translated futbol oynadım. I play guitar. Okay. Gitar çalıyorum, right? I mean that play. Well, in that case, both of them are words. that was a very wrong example. But again, depending on the part of speech tag, you are going to translate it differently, or you are going to summarize it differently. Or if I am doing a sentiment analysis, is this a positive sentence, negative sentence? Again, I need to know the part of speech tag. Okay. For sentiment analysis, adjectives are very important. If the sentence is positive or negative, it depends on the adjective, right? Good, excellent, etc. So it is important to classify the words as adjectives or not. Okay, so it's a very important subtask of natural language processing. Of course, this is not going to be a standalone application. Nobody will ask you to do part of speech tagging so that you can sell it to end users, right? End users need a translator. End users need a sentiment analyzer. End user needs a summarization tool. No end user will ask you to find the part of speech tags of their sentences. Okay, let's take 10 minutes of break. An important phone call is coming. Sorry. 10 minutes or 15 minutes. Efendim hocam.
süreci.
Heceli. Evet yani. Türkçe sınavı. Böyle hiçbir şey düşünmüyorum. Senin devamsızlıktan iyi misin? Biraz mı? Bir kere geldim.
Sen başka bir şey
Bir de sınav var.
varsa
4.
yapman gerekir.
Gel 3 kere daha yapalım.
Yoksa olmaz.
7 değil mi? Ben 7 değil diyorum.
Hiç
Öyle mi?
öyle şeyler sorgulanmaz.
Ama iyisin. Ama ben 4 ders var. Değil mi?
Altı dersi şeyin efendisini mi
Buyurun.
istiyorsunuz? Başka PL'nin.
Bu ders. Kaç ders gelmemiz lazım?
İşte ben de onu
6 olması lazım. Ben 7 diye biliyorum. %50 geçmiştir.
kaç ders çalışıyor abi?
14 değil mi? Evet, geçen hafta yapmadık tek.
Tamam,
Gördün mü?
Normalde 14 vardı.
Ben
Aynen.
ne olduğumu
Hatta
biliyorum.
hoca sınavı da saymışlar. Yani sınav
Evet,
geldiğinde
evet.
bir gün olacak diye. Ben 7 diye biliyorum o yüzden. Şimdi toplam.
6 diye hatırlıyorum. 6 nokta bir şey çıkmıştı.
Ben de 6 diye düşünüyorum ama
İnşallah 6'dır.
7 yapmak lazım. Çünkü biliyorsun değişiyor.
Bizim burada bir şey değiştiği için.
Geçen hafta sayılmıyor ama.
Geçen haftanın dersini ne zaman yapacak acaba?
Make-up yapar aynen dediği gibi.
Hmm.
Ne zaman?
Ama onu okulda yapmaz herhalde.
Ha, online yapar. Yani hafta sonu falan koyması lazım.
O zaman şey yapsın yani bizi saysın onu.
Çok seçeneğimiz kalmadı.
Saysın. Bir kere daha gelmem lazım.
Gelmek istemiyorum.
Benim de gelmem lazım. Ve piyade çok şey.
Kalp adam.
Pierre 8 istiyorum.
Yani,
Adam
Ben-
diyecek ki
Pierre 8
Allah Allah ya.
Yani
Bunu
ben
ne
artık
oynuyor?
her hafta
Burada ne
gitmem
var?
lazım.
Çalış.
Yok. Ha.
Sonra ben
artık çok
İzleyeceğim.
Ben
Şu an
de
Pierre var öyle mi?
bir kere geldim. Bir kere
şimdi bunun üzerine oynuyorum.
gittim ya.
Adam hala şaşkın. Ne yapacağız?
Alıyor mu?
Nasıl yapacağız?
Allah
Ama burada
Allah, onlar
kalmış.
çözüyor.
Nasıl yapalım? Eğer yukarı oynarsan
Kaldı
devam
işte.
edeceğiz.
Güzel, güzel. Şimdi parsele de öyle geldi.
Parseli geçen
Aynen.
Aynen.
Ama ben parsel yapmamışım.
Biraz açalım.
Sen yaptıysan
Ya,
abi nasıl
yapmıştım
bıraktın?
ya.
Niye bıraktın dersin?
Ya intern yapmıştım.
Ha,
Bilmiyorum.
abi yani parsel yaptıysan salmaman gerekiyordu.
Yok salmadım. Diğer ödevi yaptım.
Ha.
İntern yapmamıştım. Hani iki tane ödevi önce. Abi ben
Ben de herkes.
if böyle bilmem ne yapsaydım
10 dakikada geçebilirdim. Aslında kontrol etmiştim.
Ya şey intern önemliyken işte bir falan alsaydım geçiyordu.
Aynen.
İntern'den bir alsaydım geçiyordu yani.
Aynen abi. Ben de geçiyorum da işte biraz naivlik var. Düşünememişiz. Yapmamız gereken bir şey.
Niye diğer ödevi yaptım intern'ı yapmamıştım?
Sonra çok zor.
İntern çok zor.
Yani normalde zor. Hakkıyla yapmak.
Normalde ben şey sınıfın %80'i kaldı.
Tabii ki.
Böyle şey yaptım.
Bu dönem de öyle olur muhtemelen bence ya. Prologu dediğinde gene aynı şeyi isterse dedi aynı şey aslında.
Aynen.
Bir kere görmüştüm.
Soruyu satın alıyorum.
Ya işte ben 2 hafta önce
Bir dönem aynen ben bir kere
Bu dönem
görmüştüm.
gördüm.
Peki. Lale'nin o
Ben
yüzden
ayrı
şunu
bir
o yüzden
Aynen.
Teams'te falan da girer çıkarız sanki bizim
Yapacak bir şey yok.
girer çıkarız dersi.
Resmen şey dedi hangi aynı PR
Ya, sonradan
yapıyor.
İstanbul var mı peki?
Yok orijinal kimse okumaz.
Her şey yok artık.
Ya şu intern'ün notları açıklasın. Gülerim ders
Şimdi benden bir hafta önce var. Veya hepsini tek seferde görürsün. Ben hiç zannetmiyorum. Sınavı çünkü yardımcı okuyacak. Okumaz ya. Tek de hepsini atar finalde alır
Geliyor
yani.
çocuk. Onlardan birini alacağım.
Ercan Hoca çünkü üst insan. Übermez yani.
Gerçekten.
Böyle şey konuşulan bir şey
Ya
var.
geçen
Kavram
hafta
falan.
sınavı olduk bir hafta sonra çıkılıyor yani.
Abi
Bir de
öyle
4
mi?
sayfa, yani 5-6 sayfalı şey ya.
2 ders veriyorum ben.
Onlardan işte.
Bir de not
Çok
alıyormuş.
farklı bir kavram.
Şimdi doğru yapıyor diye şaşırıyoruz valla.
Abi öyle insan gibi değil abi. Makine gibi değil.
Gerçekten makine aldım.
Yani bu beklentisi de ama.
Adam günde 25 saat çalışıyor.
O var mı? O var mı alıyorsun? Digital
Bence sen bir
ben
şekilde
digital oluyorum.
kendini getirmen gerekecek.
Dijital management processing.
Tamam. En iyi dersim olmuş. En fiili bilmiyorum ne olacak. İkinci ödevi korkutuyor beni.
Sen
İnşallah
ikinci
gelmez.
ödevini çok önemli mi almıştın?
45 geldi.
Vay
abi.
canına.
Allah
Ya
razı
Allah
olsun.
ben versin. Ben yemeğini aldım.
Digital iş proses. Sami Vatan bulamayız zaten.
Aa, çok çabuk bitti
Adam
benim için.
şey adam da
Bana
bakıyor.
ne?
Evet.
Bakıyor hiç iyi gerçekten. Maşallah diyelim.
Allah yapıyor.
Ah.
Sınıf ortalaması 28 falan. Tam 86 ne var?
Evet.
Eşyalarla bir.
Ne faydası var bu?
Ya adam merakı var. Peki.
Doluyor abi kafası ya. Biz dolduramıyoruz. Katıyız. Dalmıyor.
Benim odak sürem 10 dakika sürüyor. Sınavda bile
O
unutuyorum.
da şaşırdı şu an. Neden diyor?
Böyle 6 olursa çok iyi olur.
Belki ya 6 olsun. Çok yani.
Bir daha soralım mı şimdi?
Şimdi sorsa üzülüyor biliyor musun? O yüzden
Ders
böyle-
sonunda mı soruyor?
Ders sonunda soruyor.
Ders başlıyor.
Ben de altı diyecektim.
Yok. Sonra zor bir şey. Çok üzüldüm. Benim alttan bir mevzum var. Kızıyor bana.
Ne?
Evet.
O zaman dedim bekliyorum.
Hakkında değil. Oradaki
İşte
saygım
bu.
var. Sorun
Yok
değil
zaten
kardeşim.
şey, bir masa
İyi izle.
kullanıyorum
Yanında
da.
sen varsın
Hani
ya.
şöyle yatakta
Oğlum yanında
çalışmak da
sen
zevkli.
Bir şey yapmayacağım. Şuraya
Abi
gidelim.
ben bu dersi videodan izleyince hiçbir şey anlamıyorum.
Aa,
Olmuyor.
Canlı da
kim
almıştın.
gitti lan?
Canlı gene nasıl hocanın ne anlattı falan aklımda.
Ya evet, bir de soru olunca
Öyle böyle.
soruyorsun. Ya gerçeği
Kaç kere soruldu şu an?
yok ya sordum da ya.
Geçen de yoktum abi. Videodan dinledim bu hafta. Yani hiçbir şey hatırlamıyorum. Hocam hangi black box?
Benim de ne zaman
Zaten kaybettim.
Ben şey adını anlıyorum. Hoca da olduğu için.
Benim falan ya oğlum.
Kesin şey olacak.
Ne?
14. hafta 3 tane
Sıfır öyle sıfır.
Vitamin daha önemli olduğunu düşündüğümce şu an beni çok sıkıştı çünkü.
Evet ya benim de.
Vitamin çok
Zaman çok
Ben
hızlı geçiyor. Onu
Yaptın kardeşim de sanki bana ne
Çoğu
oldu?
okulda bitirme 2 dönemde okuyor. Takım halinde yapılıyor.
Kötü oynamışım.
Siz tek başınıza yapıyorsunuz. Yani onun verdiği bir şeyler.
İyi senden ne haber? Bak gel dışarı çık.
başına yapıyor.
Ne zaman bana oğlum bugün çok sağlam bir sınıfına geldik. Arkadaşlar herkes kesin
Görüyor musun? İstersen eskisinde kaldığın yer uzayda tam eskisinde kaldığın yer olmaması gerekiyor. Bitirmen gerekiyor.
Aynen.
Genelde diğer okullarda ilk dönem araştırma, ikinci dönem eksperimentasyon.
Bizde de öyle olsa iyi olur. Datayı falan toparlayalım.
2-3 tane dersi bir derse sıçtığına göre öyle yapmazdım.
Ama ben şeyi anlamıyorum zorunda. Bu derste yüksek lisans dersi. Onlara bu test falan da okuyor tamam mı? Yani sonuçta aynı ders. Beraber okuyor. Bir saçmalık yok. Ya onlar yapılan saçmalık Gebze yapıyor.
Hatırlıyorum ben CSE'de yüksek lisanslarla
Onlar şey alıyordu abi. Bilimsel hazırlık alıyor. Tam mesela şey bitirmiş. Ne bileyim biyolojiyle ilgili alan. Programı öğrenmek istiyor.
Bilgisayar mühendisliği yüksek lisans yani siyah mısın bir zahmet?
doğru işte. O yüzden. Bakalım mezun olacak mı zaten?
Ben de ikinci sınıf diyordum ki yani dördüncü sınıf ben de yükseltme alırım dersleri.
Yani 4 sınıf kolay sanırım.
Ben de kolay sanıyorum. Ama 3'e göre kolay bence. Organizasyon yok.
Hani,
Biz şeyden olsak yani.
hani üçüncü sınıfta yani her sınıfta daha doğrusu 2 tane ana dersin yani bölüm dersin olur.
3 tane var.
Burada şimdi 3 tane var.
Bir tek bir şey var.
Biz de nasıl olacağız yani?
Bir de hiçbir yer yok.
Yeni alıyoruz.
Çok iyi bence.
25 tane yapıyoruz.
Bu hissi verdiniz mi?
Verdim abi. Sistem kavramı. Ödev yapacağız.
Yani sistem
Sistem
çalışması kolay ama ödevleri çok zor oluyor.
Hayır ya. Bir tane bir pipeline oldu ya. Onun dışında.
Benim ödev notum yüksek değil de
Ödevleri uzun
midterm'de
oluyordu ya.
Ha,
final
uzun oldu,
zordu.
evet.
Yapamadım onları o yüzden.
Ben
Yani.
finalden 40 almasam A alacaktım. Ondan şey aldım, düşük aldım ben.
Yani,
CV mi aldım, ayrı mı aldım?
ya ben anlamıyorum. Bir program senin bilgisayarda çalışıyor. Benim bilgisayarda çalışmaması ne demek?
Ya, olur mu ya? Ben hiç şaşırmadım hayatımda.
Ben oldu mu?
Ne kullanmıyor abi?
Şey prosesi mi kullanıyor?
Aynen.
Yok, fiziksel kullandım da ben de mesela şu server ödevi vardı ya, SQL ödevi. İşte Select çalışıyordu, ikimizin bilgisayar çalışıyordu, update çalışmıyor. Ondan ben de çalışıyor. Gösterdim yani, ekranın
Comparison'da mı bir sıkıntı var?
Yok hiç yani kod aynı ama onda çalışıyor. Diyor ki belki benim işlemcim senin işlemcinle farklı çalışıyordu belki de diyor. Olabilir belki onun end-to-end benim aynı değil.
Olabilir.
Yok ondan değil, belki kod sayısı farklıdır. Sen onu düşünüyor musun?
J'de de oluyor. Windows'da 5 var ya, Ubuntu 5. Orada çalışıyoruz da normal Linux'te çalışıyoruz.
Abi çok saçma ya.
Öyle duydum.
Yok, ben hepsini şeyde yaptım. Linux 5'te yaptım.
Normal
İyidir.
orijinalde yapacağım abi.
Ama ben kendim yapamadım. Olmadı.
Ben onda şeyde çok zorlanmıştım ya. Bildiğin. O query parslamada çok zorlanmıştım.
Evet. Ben query parsamadan sonrasını yetiştiremedim zaten.
Ben onu
Ya böyle böyle bir sürü if'ler iç içe falan.
Hardcode
İğrenç.
hardcode.
İşte hardcode değil.
Zaten öyle. Hardcode oldu.
Yani Java gibi substring falan. Olmalıyız.
Yok ya C'de de substring falan kullanıyor.
Ben regex yapmak istiyorum da senin regex'i normal bildiğin regex'ten farklı aldım. O yüzden öyle kaldım o kadar.
Farklı mı?
Daha farklı. Bildiğimde de o kullanıyor. Linux regex mi? Öyle bir şey var herhalde.
İyi kötü ya.
Ama ben o düzeye gelemedim. Benim kullanacaklar olmadı.
İşte ya ben yaptığım ödevi çok mutluydum. Haydi her şey çalışıyor falan. Finalden 100 alacağım bilmem ne. Ya bir de mesela orada serveri çalıştırıyordum ya soketi. Orada bir tane listen fonksiyonu var. Ben while'in içine koymuştum. Hoca diyor ki niye while'in içine koydun? Bir kere listen yapıyorsun. Dedim ki hocam yani ne bileyim yani gözümden kaçtı.
Kaç tane query var?
25 puan kırdı onlar.
Bende de while vardı.
Yok while'in dışında koyacaktın listen'i bir kere listen yapman lazım diyor. Gözümden kaçtı dedim hocam. Tamam 25 puan kırdı.
Hoca da bana çok sinirlenmişti. Daha eski bir signal handler kullanıyorum.
Ama bir
Siz
şey
de
sen
pozitif sanmam mı?
kullanmayın dedi.
Ha,
ama
işte onu
muhtemelen
kullanmayın.
dersi.
O çalıştı abi, yapamadım diye Allah Allah.
Geçelim artık. Hocam bu sene mezun olabilecek miyiz?
Ben bilmiyorum. Mining'in vizesi çok iyi geçtiriyormuş. Önceden o kadar performanslı bir seviyede demiyorum ama hafif almamak lazım.
Zor mu?
Zor var. Çok zor ya. Çok fazla tanış olmuş.
Tamam ben de düşünüyorum onu. Yani full programlama yani analiz dersinin nasıl bir yazım vizesi olur?
Argument'ları neler
Bileşimleri falan mı sormuş?
Yok, parametreleri neler veriyordu? 5 tane falan sordu. İlk soruda İngiliz falan. Algoritmanın parametreleri neler? Parametreleri nasıl optimize ederiz falan diyor. Algoritmanın çalışma sistemini anlatıyor.
Niye soruları?
Öbür soruda pseudo kodu yaz dedi. Öbür soruda da böyle 20 elementli bir datasetin varyansını hesapladı. 2 element arası. Aynen. Uzun sürdü yani. Oturup topladım hepsini. Sonunda bildiğini falan.
Kaçta ara vermiştik arkadaşlar ya?
18 hocam.
18. 15 dakika oldu mu yani?
Geçti, evet.
Ha, 15 dakika olduysa ben odama gitmeyeyim öyleyse. Tamam. Ben yoklamayı unuttum. Neyse bir saat sonra getireyim. Okay, so this is what part of speech tagging is. That's what we are going to do. Okay, so for English we need to know what kind of tags we have. We know already these are nouns, isim, verb, fiil, adjective, sıfat, etc. Okay. We don't have. Do we have prepositions in Turkish? On the sidewalk, at the table, in the house, etc. No, we don't have it, right? Preposition yok değil mi Türkçe'de? preposition. No, adverb, of course, zarf, article, interjection, pronoun, etc. So we have many of them, but some of them are in English. And the thing is that doesn't matter what kind of part of speech tags we have for English or Turkish. The experts on these, okay, experts on these linguistic experts, they cannot agree on the number of tags for English anyway. So some of them say that we have more than 100. Some of them say that 50 is enough, and etc. Okay. So the important thing is that as computer scientists, okay, we are going to assign tags to these words one by one, okay? No words will be left unassigned, and that's what we are going to do. And we are going to ignore, okay, how many parts we have. We are going to ignore what kind of parts we have in English or Turkish. Usually we have these, okay, 8. These are the 8. How many? 7. 7 tags that are most common, okay. Noun, verb, adjective, adverb, preposition, pronoun, and determiner. We don't have determiners and we don't have prepositions in Turkish, but rest of them are there. Okay, so I already said this. Sometimes, again, why are we doing this? For speech synthesis. Sometimes it is object and object are two different words. One of them is a noun, the other one is a verb. And I don't know which one is which. But when you start with object, okay, object, this is verb, this is noun, okay. This is just nesne in Turkish, itiraz etmek in Turkish, right? And discount and discount, again, two different words. If I assign noun, okay, noun and verb tags to this one, then my speech synthesis will be correctly produced. Okay, if I am producing a speech, then it depends on what kind of tag this one has. Again, for the parsing, it is important to know if a word is a noun or a verb. Information extraction again, okay? Information extraction. When I say extract, okay, some information about this and this, if you are scanning the simplest form of information extraction is keyword matching. You just, using Control F, you just match the words, right, one by one. But if you do that, for example, that word put, if you search the word put for all the instances of it, sometimes you're going to catch verb put, sometimes you're going to catch noun one, sometimes it is adjective, etc. So it is information extraction. You need to know what kind of part of speech you have for your words. Of course, the machine translation is very important. Okay, I don't remember what I did last time here, but you understand why this part of speech tagging is useful. One important detail here is this. In the old ways of, when I say old ways, maybe I'm talking about 10 years ago, part of speech and parsing were integral parts of the machine translation or information extraction, etc. Nowadays, we are doing machine translation using parallel corpora without knowing anything about the language itself. We say that, okay, this is Turkish Wikipedia, this is English Wikipedia. These sentences correspond to each other. Learn from this and do the translation. That's how the things are working nowadays. Or better yet, this is what we are doing. This is English Wikipedia, this is Turkish Wikipedia. I am not going to give you any correspondences. There is no correspondence function available. Okay. I am going to give you 1 gigabyte of Turkish text. I am going to give you 2 gigabytes of English text. Learn from this, do the translation. Nowadays, this is working very, very well. Okay. It is not as good as the parallel corpora examples, but it works very well. It works better than the top translator of 10 years ago. Okay, so it's going to be better than the supervised translation. So what I'm saying is that nobody is doing part of speech tagging anymore for the machine translation or summarization. Okay, so you might think that this is kind of an outdated natural language processing task, and I wouldn't object to that. But while we are talking about, again, part of speech tagging, like I did before, we will talk about dealing with the sequential data, okay? We will talk about the Markov chain, see the Markov model, okay? So that will be a good opportunity for you to learn about these kind of models. Maybe you know about them from the programming language classes or the formal language classes or some other place, but this will be a very good example of looking at this kind of data using those kind of model. Okay, good. Okay, so some of the classes, some of the tags are kind of easy in a way that you already know the number of prepositions available in English, right? You cannot make up new preposition words. Prepositions are of, in, by, and etc. The number of prepositions, if you add them up, maybe 50, maybe 100. That's it. Okay? You cannot make up new prepositions or auxiliaries. Very limited set. Pronouns, etc. Okay? These are closed class words. Okay? A small fixed membership. Okay? Maybe these are kind of easier compared to the other ones, which are the open class words. Okay? So nouns, for example, nouns, verb, adjective, and adverbs. Even non-English speakers, they can make up nouns or verbs, right? And they can use the nouns or verbs in the place of the other tags. Okay, and these are open class verbs, and we don't have any limit number of words in this set, but these are limited. That's why they are closed. So many languages have all these four, but so there are some languages maybe that all four are not that different. For example, in Turkish, sometimes we are confused about adjectives and adverbs, right? Güzel koşarım, güzel çiçek, right? One of them is zarf, the other one is sıfat. But in English, you don't say well rose or well flower. You say nice flower and I run well, right? So in English, I think the difference is more pronounced, adverbs and adjectives. In Turkish, yeah, we differentiate them, of course, we differentiate them, but we differentiate them in terms of their tags. Mostly our adverbs and adjectives are the same word, right? English, it is different. Slow is adjective, slowly is adverb. Okay? So there are these kind of differences, but it looks like some languages don't have some of these classes. Maybe like Turkish, they are in the same group. Maybe I don't think that there are any languages that that wouldn't separate nouns from the verbs. Okay, so nouns, the open class. Okay, inside the nouns we have proper nouns. Maybe this is the largest subset of the nouns, because in the world there are millions of human names, millions of village names, and the city names, and the names for the periods of time, names for the etc. You know that, right? So proper nouns, common nouns, noun constant, etc. These are all nouns. And we have adverbs, okay, tend to modify things, and we have verbs. Okay, so adverbs, they tend to modify verbs, right? Not things. Okay, is this yesterday? Yesterday is adverb. It is modifying this walk, right? I walked yesterday. Yeah. etc. So, and we have the verbs. Okay, so these are the closed ones: preposition, particles, determinants, etc. So let me move a little bit fast on this one. Conjunctions, auxiliaries. We have this. No, we don't have it. Maybe we have this one in Turkish, not this one. We have this one. We have this one. Not this one, of course. This one. Okay. So there is a select data set, corpora, if English sentences, and if you look at the prepositions, how many of them are happening in the selects? As you see, this of is happening a lot. One of the two, of the man. Okay, so this is 500,000 times, and there are some prepositions that didn't know that this is a preposition. Well, this is a made-up preposition. I think it is true. It is true. Yeah, it is here. And these are old English stuff. And there is a but here. But is not a preposition, but it looks like they can use but as a preposition too, right? So but is a connective, right? So, okay. But as you see, the number of prepositions is this many: 10, 20, 30, 40 at most. And the same thing for the particles. Okay, particles is more, but we are not talking about thousands. Okay, conjunctions, what happening? Okay, and where is my conjunction but? Yeah, here it is. Okay, so and is happening a lot. Well, very surprised. And or, yeah, well, that's expected that. Since any surprises?
No.
Any surprises? Yeah, as if. I don't know why this is not happening much. As if. As long as.
Without.
What is without is happens 0 times?
Yes.
Really? Well, there's something wrong with it. Maybe they don't take the without him, without that, without. Maybe it's a preposition without.
Yeah, this is conjunction of a
Is
preposition.
it is the preposition? Where is without? Within. With. I don't see it. Anyway, we are not linguistic expert here. We are just trying to understand our data. And the point that we need to take out of these tables is that even with these kind of closed tables, okay, closed sets, what we are going to do, what we are observing that one word can belong to more than one table too. So there is ambiguity in there too. Remember what we said at the beginning of the semester? Whatever we do with the NLP stuff, there is always will be ambiguity. If there is no ambiguity, there is no NLP or AI stuff. Okay. If there is no ambiguity, then you are doing Control F. Okay. That's not NLP. That's counting the words, or that's counting the letters, or doing the pattern matching. Okay. Choosing the tag set again. This pan tree bank tag set has 45 tags. And you might be surprised, well, why is it so large? Remember when we look at the put, it says that put is either a transitive verb, an intransitive verb, right? Okay, put the keys on the table, transitive, okay? And put with me, and then it is it I don't know, but it is used in that way. It is intransitive, and for each one, I will have a different tag for this one, 45. So it seems a little bit large, but there are even larger tag sets that we will see. More than 100 tags for some of the data sets. Okay, so this is the pan tree bank. Let's look at them because we are going to use them. Some of them are really used, some of them are not. For example, if something starts with a J, it means adjective. Okay. JJR, it is comparative, that is bigger, larger. Okay, JJS is superlative wildest. Okay, so under the adjective, I have 1, 2, 3 adjective classes. Okay, tags, sorry. And nouns, okay, NN is a singular noun, NNS is not singular, NNP is proper, NNPS is plural, okay, proper noun. Okay, what else? And adverbs. RB means adverb, okay, regular adverb, quickly, never, comparative, faster, fastest, okay, superlative. Okay, so I never thought about that, okay. Quickly, quicker. You don't say quickly, right? So this one and this one is written the same way, but one of them is JJR, the other one is RBR. Okay, what else? And our verbs. Base form verb, okay, past tense verb, ing verb, VBG, past participle, eaten, and non-third singular present tense, the VBP, and singular present, eats, VBZ. Okay, good. So verbs and nouns, adverbs and adjectives are the ones that we are going to deal with more often. Let's look at this weird stuff. Dollar sign has its own tag. Pound sign, for some reason. Left quote, right quote, parentheses. These are the stuff. Sentence final punctuation is different for this kind of stuff. And mid-sentence punctuations. What are these? Column, semicolon, ellipses, and etc. What?
M and dash.
Yeah. Okay, good. So this is the pen tree bank, total of 45 tags. One example. The grand jury commented on a number of other topics. Okay? So for each word, I marked it with a determiner, adjective, noun, verb, past tense, preposition. In has its own class, right? Okay, preposition, and all of them are marked as by in. Now, in doesn't have its own class. All the prepositions are put in. And determiner, a, this is a noun, another preposition, adjective, and NNS, okay, plural noun. And this one is a end of sentence punctuation. Okay, good. Two has, I was confused about it. Two has its own, its own tag too. But again, there is an ambiguity with two, okay? Except the preposition complementizer, two is just marked two. So if I use two as a preposition, I am going into the school. That two is a preposition. That two is marked with an in. But if I am using two with a verb, to go to school, then two is two. So somebody made the decision on these tag sets, and they have tagged all the sentences, millions of words in this pen data set with these tags, and it is available. Okay, let's look at this confusion or the ambiguity about back. Back could be adjective, noun, adverb, or adjective. Okay, so the back door, of course, the door, back. Okay, this one modifies door is adjective. On my back is noun. Okay, this is noun, this is adjective. Okay, this is win the voters back, adverb, and promise to back the bill. This is verb. Okay, 4 different tag classes for the word back. What did I say? If the word is a popular word, frequently used word, the chances that it belongs to more than 2, 3, 4 classes is more. Okay, and this is our basic problem. Determine which class does the back belong to given the context. Okay, how hard is part of speech tagging? Okay, so this is tree bank. Remember, pantry bank, 45 tags. If I mark the same set with 87 tag original brown tag set, this is what happens. Okay, for let's say in my dictionary I have about 50,000 words. Okay, out of 50,000, 38,000 of them are okay. They don't have any ambiguity. Their tags are known. Okay, for the tree bank brown. Okay, for the original tag set, 45 tag set, but only the 44,000 of them has only one tag if the tag is 87. Okay, and out of all these words, 9,000 of them, okay, 9,000 of them are ambiguous. There are 2 to 7 tags in it. Okay, so what is this? It is like what is the total? What is 50,000, right? So 80 over 50. How much? Like 20%, right? 20% of all the words are ambiguous. We don't know the real tag of it until we see it in the sentence. Okay. So out of these 88, 100 of them, 6,000 has 2 tags, and the number is dropping by. And if you look at this one, this word well has 6 different tags. This word set has 6 different tags. And that, more, and in have 9 different tags, right? The one, what did I say? 6? Sorry, 7. The word well has 7 tags, possible tags. And for this 45 tag set, the word that has 9 tags. Okay? So out of 45, I can use 9 of them to describe that, depending on the position. Well, I mean, the same thing is valid for Turkish too. Okay? If it's a natural language, ambiguity cannot be avoided. For some places, maybe ambiguity is less. Some places, for ambiguity is good. And in Turkish, we have the ambiguity of the part of speech ambiguity is a little bit less, because usually, since we don't have the preposition, that kind of stuff, we don't say to school, we say okula, right? So the word itself, by morphology, the word itself includes the word itself and the preposition in it. Okay? So we don't get confused about the preposition at all. So the preposition problem is automatically solved by the morphology. But morphology problem is more difficult in Turkish, right? I mean, in English morphology, remember, it was simple, especially for the verbs. But in Turkish, it is very, very difficult. And that difficulty in morphology makes these kind of problems easier for the rest of the analysis. But morphology is very tough problem for Turkish. So I am not saying that Turkish is better in terms of processing or English. These are just the differences. Okay, so what are we going to do to solve this problem, part of speech tagging? Of course, as always, we start with a rule-based system. if-else systems. If this and this and this, then do this. Okay. Else do that. And as you might expect, this will work up to some point very well, but after that it will get out of hand. It cannot be controllable anymore. And then we have the stochastic approaches that includes the probability. Okay. And by the way, when you give one, like for example, a 1,000-word sentence or 1,000-word paragraph to an expert in this area, or give it two of them, two experts, they agree on maybe 95% of all the tags. On 5% of the tags, they won't get on the same page. They won't agree. It is not because they are human and they are making mistake. Okay, you tell them that you mark this as tag 1 and the other guy marked it with tag 2. They start arguing with each other. Okay, they know what they are doing. It is not a human mistake. They say that it has to be this or it has to be that. Okay, so they have their opinions. So there is a human sealing problem in this part of speech tagging too. Okay, so again, typical artificial intelligence problem, typical ambiguity problems. And that's why if we have such problems, then stochastic approach is going to tell me that there is a 90% possibility that this too is to, not the preposition to. That's what we are going to find. Okay.
A quick question. We're doing all of this assuming that the text is 100% correct. There are no mistakes.
No. There is no 100 correct assignment of the tags. No.
No, I mean the text itself. It doesn't have spelling errors.
Yeah, you're sure, yeah. Yeah. It doesn't have any spelling errors. Okay, so let's look at this rule-based tagging. I start with a dictionary. Okay, like the Merriam-Webster that I started, as you know, okay? And for each word, I pick all the tags from the dictionary, this one, this one, this one, and I start running these rules, okay? I start running these rules. Those rules will tell you, okay, if this happens, this cannot happen. If this happens, this cannot happen, okay? And at the end, I am hoping to have only a single set of tags for each, single set of tags for each word, okay? For example, let's take this example. She promised to back the bill, okay? And simplify the problem. I looked at the definition of she in dictionary. It says that it's a pronoun. Okay, that's one thing. Promised, it could be verb or verb, but okay, what is the difference between these two? Do you guys remember?
One means
Past,
noun,
second
one
is
means
past tense.
Past tense and past participle stuff, yeah. The second form or the third form of it. Okay, this one. To is to, back is again 4 different classes. Determiner, bill is either a noun or verb. Okay, so how many possibilities out of this picture exist? 1 times 2 times 1 times 4 times 2,
16.
so 8 times 2, 16 different possibilities of assignment. Okay, which one is correct? One of them is going to be for me correct, but usually what did I say? I prefer assigning a probability for each path. There is no single perfect solution for this kind of problem, but the rule-based system will tell you that this is correct and this is not. Maybe that's the reason why it is not more successful than the probabilistic approaches. Okay, so let's look at some of them. Okay, this is what I'm going to do. I will just eliminate. Let's eliminate this one and this one and okay. So what is my rule to eliminate this second form of the past sentence? When you say she promised, it cannot be, okay, simple past tense. Why? Because it has to be she has promised, right? Okay. So I'm going to eliminate that one. If I see a 2 before the back, okay, just eliminate these 3. And if I see a the before the bill, then eliminate the verb option. Well, I just simplified these rules, but these rules are like that. So If you keep writing these kind of rules, okay, eliminate this one, eliminate this one, eliminate this one. At the end, you will come back with just a single assignment for each word. Let's look at some of the rules actually. Eliminate VBN if VBD is an option when VBD follows start preposition. You got this right? Exactly the same thing happening here. If at the beginning of the sentence you have start preposition, right? Beginning of the sentence starts with a she, okay, is a preposition. If I have both of them are available, VBD and VBN, okay, then VBN can be eliminated. That's why I eliminated VBN. This is one of the rules. Okay, so I eliminated this. Now instead of having 16 different alternatives, I have only 8, 4 here and 2 here. Yeah.
Do we do sentences by sentences?
What?
Sentence by sentence.
Well, in this case, yeah, we do sentence by sentence.
So we need to separate sentences.
Exactly, yeah. Yeah.
This is another problem.
Sentence separation is a problem, yeah. We do, especially for Turkish. In English, usually the sentences end with a dot or period or question mark or the exclamation mark. But in Turkish, we use period for some other purposes too, like İkinci Dünya Savaşı, etc. Right? So it is difficult, and as you might have remembered, for some languages there are no spaces, right? So you don't put spaces between the words. Okay? For those kind of languages, it's a problem to segment the words, also segment the sentences too. Okay? But that's a problem. And English is a problem too. But we are assuming that I got the whole sentence, and I am assigning tags to the elements of that sentence. But maybe the more correct thing to do would be assign those tags to the whole paragraph, because depending on the context of the paragraph, depending on what I am talking about, you may change your decision from one tag to another tag. Okay? So I am not playing a guitar like the çalmak playing. Maybe I am really playing with the gitarla oynuyorum herhalde. Bilmiyorum. Okay? Sometimes it can happen. Okay, so this is just one rule. Okay, so that's what we do. First, run words through finite state transducer, morphological analyzer, to get all parts of speech. Okay, that's going to produce all parts of speech for me. So this one, okay, noun, nominal noun, singular and proper, it told me. This one is have, okay, it's a verb, past tense, and etc. I did this, so I have all the possible tags. Remember, the morphological analysis tools will give you many alternatives. It will not tell you just that this one, for example, this one has 2 of them. What is the difference between these two?
It might be past or past participle.
Yeah.
But sure.
This is past tense stuff, had or have. PCP2? What is PCP2? I don't know what kind of... Do you guys remember PCP2? Is it in our tag set of the pen tag set?
No, maybe it's from another set.
Yeah. Participle?
We said there's another set with
Yeah.
80.
But there are many other sets. what could have been? I think it is participle. I don't know. I mean, just how about this one? This one again. This one is, yeah, past participle. Have, had. Okay, good. Again. This, yeah. It is the second form of the past, simple past tense or the past participle, right? And this one is definitely participle. And this one is either adverb or pronoun or determiner or whatever the CSE is. Okay, so these are all given by the morphological analyzer, and then after that we keep running all those rules. Apply negative constraints. Okay, for example, for the adverbial that rule, okay, adverbial that rule says this: eliminates all reading of that except the one in the it isn't that odd. Okay, that in this case is not a pronoun or preposition or that kind of, it is adverb that. Okay, what does it look at this one? It looks like you know Lisp, right? You have written code in Lisp. Okay, very important language, don't forget about it. Okay, so this is kind of expressed in Lisp. +1, +2, a adverb. If next word is adjective adverb quantifier, yeah, so +1 means that whatever comes me after that is adverb, adjective, or quantifier. And after that, if I have is an end of sentence mark, right? And this is not, my previous word is not a subject, word, object. C is not a verb like consider, which allows adjective complements. And in that case, I consider that on. Okay, in that case, it is adverbial that. Then eliminate non-negative, non-adverbial tags and eliminate adverb. Sorry. Then eliminate all the others, otherwise eliminate adverb. So we are going to make this decision. Either eliminate all of them, all the rest, or eliminate adverb. Okay? This isn't that odd. It says that this should be at the end of the sentence. After that it should be either adjective, adverb, or quantifier. Okay? So one example. So who writes these rules? A person who is an expert on the field of linguistics, okay, sits down and writes these rules, and there are literally hundreds of rules like that, okay, and it works up to some percentage fine, but after that, when you introduce a new rule to fix a problem in your test set, okay, that rule causes other problems for the others, so there are conflicting rules. Okay, there are rules that don't agree with the other rules, or there are some problems that needs many rules, and that makes running this a lot difficult. Also, you don't remember how you handled one of the cases, and those cases depends on which rule you are running first, and etc. So it becomes a nightmare to deal with this kind of rule-based system. So up to 90% you are fine. After that, it becomes a problem. You might say that, well, up to 80% I don't have any problem anyway, right? Remember, 80% of the words doesn't have this ambiguity, only 20% of it. So this is not achieving much. So instead of that, we are going to start talking about probabilities and then statistics again. Let's not try to eliminate all the possibilities. Let's use a probabilistic model. In this case, we are going to use this hidden Markov model for tagging, and it's going to be a kind of perfect fit, best compromise between the finding the correct one and running the tractable algorithms. And that's what we are going to look at. But before that, we are going to take some break. Before the break, maybe I can take a question or two. Any questions? Okay, any questions? We will come back and start your questions. Okay, so let me not forget about your attendance. 15:30, and I am going to my room and I will print out the attendance. Dışarı çıkmayın diyor ya.
Hocam fırtına geliyormuş. Büyük bir fırtına.
Kaçmamız lazım.
Ağaçların altında
Abi işte söyledi artık. Abi çok şey vardı, rüzgar vardı, lodos vardı.
Sen kaçta oturuyorsun?
22'de.
Böyle şeyin kapısı var.
Dersen arkadaşlar. Oldu mu?
Yüzde bir kişi de oluyor. Arkada.
Dışarı çıkmak. Bir anlıkta hakim bir anlık çok kötü. Niye ki? Çok kasıyor. Benim hepsini de yakın. Ama bir şey bakmam lazım.
Ne?
Ne?
Ölçüm dışı mı?
He. 12. bakmam lazım. Bütün ekran kartım. Bir yanında vardı.
Ben bir saniye yazayım.
CSE'nin anındaki kodun hepsini verdim. Önce kasıyor.
Bir de onun geri dönüşü var yani. Kötü yani bayağı olmuştu.
Kanka yok. Gönderemiyorsun ki. Gönderebilsen gönderirim de. Çok garantiye bir muhabbet yok.
Malta'da mı gideceğim?
Bugün gitmeyeceğim. 5 dakika falan oldu.
Yetişemez.
Yarın abi. Ya nasıl?
Gitme abi. Kulübe gitmem. Tamam gidelim değerler. Belki yıldırım falan çeker. Nişaçta 2 kuşağı.
İşi için öyle şey oldu.
Sana abi. Hava kimse şeyden soğuk.
Ama çok sıcak bir şey. Ben alışıyorum da çıkarma şey. Şu an rüzgar yerde donacağım şimdi. Yazın rüzgarı da var.
Bizim teknoloji var. Daha yüklenmiyor. İnternetten yükleniyor ama işte hani saat gösteriyor böyle.
Böyle gidiyor işte.
Fırtına daha bize gelmedi ama bulanık 9 katı binası alıyor, çok dağıldı diyor. 29 Kasım'da gün mü? Tuzla sesimiz sakinlikle tutuyor. Bekle bakayım, aslında bir not yapıyorum. Şöyle birkaç şey videosu izleyeyim, fotoğraf videosu izleyeyim.
Ufak mı?
Niye?
Kısa markasını kullanıyorsun.
Tabii. Firefox. Bu eski video. Bu komik video bak şimdi. Bak. İşte okul bu yüzden diyor. Yoksa insan olur ölmeyin diyor okul. İzmir'de de varmış yani.
O Marmara bölgesi.
İstanbul büyük.
Hangisi? Yak var, refleks var.
O C'de, C'de öyle.
Yani küçük rüzgar
Şey yok da abi böyle
Ama şey çok artı olan yaklı olan şey olan.
ha yaplı olan.
Ha yaklı olan. Evet. Ama onu ben geçen de bir daha sordum. Baktım ben ona şey S'de yapmışım.
Tamam.
S'de bazı bazı fonksiyonlar istediği.
Kaçıncı sırada abi?
Ne ya?
Kaçıncı sırada?
İsmi.
Bilmiyorum.
Eğer yaparsan görürsün benim maksimum 300
Türkiye'de Amerika'daki
çünkü şey yapmıştım hatta ben hatırlıyorum.
işte
O ikinci yani. Flex'te olan üstüne böyle bir şey ekleyip denemiştim. Aynen ama şeye bakalım. Ona yetmişim.
Abi öyleydi zaten. O dönem vermek gerekiyordu. Ben biraz şey düşünemedim.
Valla işte
sen
şimdi aldın mı?
Baksa ne kadar makyaj yaptılar
formasyon oluştursana öyle
İşte şeydi. Sınıflara bakıyor. Onlar bayağı iyiydi.
Aynen.
60 sınavlar
Olur kanka.
tabii yani benimkine bakabilirsin diye. Bende rapor da var ama şey dediğim gibi eksik.
Olsun kanka ya.
Hesabı lazım.
Ben de bir
Kötü bir
sınava
kameraman
uzun
yani.
yazmışlar.
Oğlum nereden
Şeye bak.
Çok onlar böyle
Değiştiremem yani o kodu. Hoca
öyle anlaman lazım. O adam bir saat çalışıyor aşağı doğru iniyor.
bunun devresinden
Ben de hatırlıyorum
Başka bir
Rispi dediğim gibi o değiştiren C'yi alıp bizim gibi data structure kısmını o C'de şey yapmıştı ben link sistemi yaptım. O şu yapmış ben link sistemi yaptım. Böyle değiştirdim. Bunları hatırlıyorum ben yürü attıktan sonra Yarıda muhtemelen şu anda biliyorsun.
gidelim mi Beylikdüzü?
Yani şimdi koçun olacaktan buraya gidiyor. Hep o dönüyoruz.
İşte biz tam merkezini görüyoruz.
O da işimizi görüyordu.
Yani buraya geldiği zaman hafifleyeceksin ben çok.
Çünkü şey de farklı biraz.
Bu fotoğraftaki
Bu attıklarım benim hep şey istemez. Yani bizden bir önceki adımlar orada aslında özlü hocam. Hatırlıyorum onların kontrolü de farklı. Anladın mı? Yani mesela özlüğü tamamen sayılıyor. Fiziği vereceğine İstanbul deneyi kuşuyor. Ama şöyle bir annenin birini verdiği bir çocuk da yani soru yapmış. Özlüğü atmış.
Aynen aynen.
Öyle, çünkü çok karışık noktalar var. Bunlar anlatmak çalışıyoruz falan. Detaya gidiyor.
Yok kanka ben.
WhatsApp'ın birbirini yiyor. Yok işte iki tane artı, üç tane artı yayın olacak falan.
Abi çok zor oldu. Şey yaptı ya. Bir anda tanıdığı çağırman lazım.
Aynen öyle.
Ama onu kim yapacak? Ben yapamadığım bir şey yapamam diye sordum.
Böyle bir görev var diyor ya. Ben bunu istiyorum.
Öyle değil.
Aynı altında hastanesi.
Ya şey işte ne yaparsan gönderiyor.
Aynen öyle.
Yani
Yapabildiği kadar gönderiyordu, geçiyordu. Yani iyi yaptı.
yani bir yerlerde öyle bir konflik istiyor. Psikolojik baskı dersler. Orada olayı kavrayıp bir strateji işaret edersen
Abi ne olacak kırık yani? Adam sadece
mesela ödevi bir tane güzel bir sonraki ödevisi Çıkmama ödevi yapacağım. Ödevi bu yüzden
Neymiş evin çatısıymış lan.
İşte o dans edenler
iyiydi ya. İyi bir konuymuş ya.
Çok iyi abi.
Aynen.
Bizim partide şamarlı.
Şey,
Ne kadar
Fatih Fatih.
ha olaymış ya.
Türk bayrak düşmüş.
Şey başlayıp yüksek nokta
Sağlık bayrak değilmiş.
Öyle söylüyorlar.
ödevi şey, özel gibi diyorlar ya, aynen yani çok oyun yaptırıyor. Bir de çok step var. Ama zevkli ya var. Biliyorsun yani. Ben dediğim gibi adamla falan gidiyorlar.
Üçten içerisinde pazar nereye gidiyor? Yavaş yavaş
Yıkıldı mı? Yani adamlar var falan.
Abi
Biraz daha iyi.
O bile
o zaman hoca
değişti.
Erdoğan hocası da tamam
Kesin gerek olmuş.
Adamın sıfır şu an. Hiçbir şey yok. Bir şey girmiş canım. O şey. Böyle simsiyah sütun vardı o gördüğüm yeşil.
Hayır, hiçbir şey yani.
Canlı organizma aldı.
Hem orada dobloyla gelen adam işin içine heyecanla katılıyor. Ve yalancı kadın bir aksiyon. İki saniye.
Diğer monitörde. Yani en güzel ama işte
So let's look at the other idea of assigning these probabilities using these techniques, hidden Markov models. Okay, the idea of using hidden Markov models is not, of course, nothing new. Hidden Markov models are actually have been used since the first day of the invention of the computers. In 1959, for example, they used it for optical character recognition. Okay, in 1964, authorship identification, etc. And it is somehow related to the noisy channel model that we have looked at previously in the previous chapter, and we are going to use the same method for this purpose. So with the let's look at these words actually. The Markov model and hidden. What is hidden and what is Markov model? Okay. If I have a state, okay, state changes, okay. For my case, my state will be, for example, I am reading a sentence word by word, okay. At the beginning, I have a pronoun, and then I have a proposition, okay, and I have a verb, then I have a noun, and I have a punctuation, for example, okay. So this is a chain of events, okay, and I can always measure. I can do this calculation. What is the probability of having a pronoun, then a proposition, verb and noun and punctuation, etc. These are the things that I am after, but I cannot see them, okay? All I can see is this. I can see a word, she, okay? I can see, what am I going to do now? It's the proposition to, okay, I'm making up some stuff now. Read and book and a punctuation dot. So in the observable universe, okay, I see, can I make it a little bit more correct? She okay, she wants, and this is verb, and let me make it a two. Okay, so I see this sentence from the real world. This is what I am observing, but behind the curtain, behind the scenes, this is happening actually. These are hidden from me. That's why we call them hidden. What is the Markov model? Markov model is this, okay? Markov chain. There is a chain of events are happening, okay? So the Markov model is running on this chain. It is trying to make sense of what is happening after what, okay? And my observations are trying to make sense of if I am observing this, what is the probability of having a pronoun? If I am observing this word once, what is the probability of having a verb? Okay, so these probabilities will come from the dictionary or from the statistics, and these probabilities will come from my previous experiences of the sentences. Okay, so this hidden Markov model has some sound assumptions and some very strong theory about assigning these kind of probabilities to what have you observed. There is another classical example. It says this. For example, last summer, I don't remember how hot the day was for a given sequence of days. For example, June 10th, 11, 12, 13 and 14. Okay, 13 and 14 last summer. I don't remember those. I don't have a record of how hot that day was. But for some reason I kept records of how many bars of ice cream I have eaten. Okay? So why are you laughing? This is a very classical example of NLP.
Really fun thing.
Okay, yeah. So
Keeping track of how
as long as you listen to the lectures, you can do. Okay. I can recover the number of bars of ice cream I ate last summer from my credit card reports. Okay. So on to June 10th, I ate 2 ice creams, and 1 and 3 and 0 and 2. So these are the observable stuff. I like to okay, find if that day is hot day or cold day, hot day or cold day. So these are definitely depends on each other, and there is this dependency too. Okay, so what is the probability that I ate 2 bars of ice cream on a hot day? High. What is the probability that on a hot day I ate 0 ice creams? Okay, very low. So what is the probability of having 2 cold days, one after other, on a summer day? Okay, so this is the thing. So all I am observing is this. 3, 2, 2, 2, 1, 3, 0, 2. And I'm trying to guess these. It is exactly the same problem. I am observing these words, but there is something latent. There is something hidden behind these words. Okay, I'm trying to make these assignments. And as I said before, you will see many examples of this in many other fields of the computer science or engineering. Okay, if I observed this measurement from my thermometer, what is the real? What would you think that the real temperature is? If my car is measuring this speed, okay, using this speed measurement device, what is the actual speed, etc. If my car is, my sensor is telling me that, okay, my sensor is telling me that I am using 2 liters per second oxygen. I can measure it. So what is my real fuel consumption rate, actually? Okay. So these are all examples of hidden Markov model cases. I can use them. If you have sequential data, time data, one after the other, and you have some observations, okay, then you could do that kind of stuff. Okay, good. So let's go back and let's try to model our problem that fits into the formal definition of the hidden Markov model. Okay, so part of speech tagging is a sequence classification. Okay, we are given a sentence, an observation. Okay, for example, the secretariat is expected to raise tomorrow. Can somebody translate this into Turkish? Somebody translate this into Turkish.
Sekreteriyatın yarışması bekleniyor.
Söyle.
Sekreteriyatın yarın yarışması bekleniyor.
Sekreteryanın yarın yarışması bekleniyor. That's good. That's how I would translate it if I didn't know what secretariat is. Secretariat is a horse name actually. They gave these kind of funny names to the horses, right? So I mean, how are you gonna know? Well, you need to know the culture and etc. But so that will be the case. So what are the confusing or the ambiguous names here? Race could be noun and verb, etc. So we are going to find that. Okay, what is the best sequence of tags that correspond to this sequence of observation? So that the probabilistic view is going to be this. Okay, it's going to be this. If somebody says race and question mark, okay, what would be the most appropriate tags for T1 and T2? Okay, so arg marks T1, T2, assign these two marks for this one, that will make this probability high. So how would you do it? I think I would calculate this T1, T2. For example, how many tags do I have? 45, right? How many possibilities of T1 and T2? 45 times 45. So that makes kind of this much. If I assume that it's 50, 2,500 possibilities. I would test all the 2,500 possibilities, okay, and I measure this probability. Whatever makes this maximum, I say that, okay, this is my case. But the thing is that calculating this for a given, for example, how am I going to calculate verb and noun? How am I going to calculate this one, verb and noun? So I will have to go through all of my data set, find all the occurrences of race, question, race, exclamation mark, and find all the assignments of V and N, and out of all these assignments, how many times this has happened, and do that. But it looks like you are not going to find this in your data set. Okay, this is a very rare occurrence. That's what we did with the. That's what we have seen with the. Remember, n-grams, and we will run into this kind of problem. So we will have to do something else. But our main idea is consider all possible sequence of tags. Out of this, all possible sequence of tags, find the correct assignment of it. That's what we are going to do. This is my observation, my words, and assignment of the tags. Okay, find such tags that find such tags that makes this probability maximum. So how do you do that? This is how you do this is the definition of the conditional probability, right? So find how many times these tags and these words come together and divide the probability of these words. Maybe I can calculate using the n-grams, but finding this is not that easy, because even if you use all the printed text in Turkish or in English, you will not find it. And furthermore, you want them in a marked way, you will not find it. Okay, so we need to do some approximation, some stuff. So you know the idea, right? What we're going to do, we are going to just use the bias rule, just write the opposite way. We will make some approximations, and after the approximations, we will kind of be fine. So getting the HMM, that's what we are going to do. We already wrote this, right? Okay. Good. I already write this. Okay, so how do I make this operational? How do you make this manageable? Given this data, this much data, how am I gonna find an approximation for this expression? Okay, again, we use the bias rule to transform this equation into a set of other probabilities that are easier to compute. Okay, that are easier to compute. So what do I mean by easier to compute? Okay, it will be clear this way. Using the bias formula, okay, I am writing the same thing here. So instead of writing this p given words from 1 to n to tags 1 to n, I write it this way. And say that ignore this part. Did you get that one? Ignore this part. Why are we ignoring this? Because this one is same as this one. This is not an approximation, see? This is exactly equal to this one, and this one exactly equal to this one, so I am ignoring this lower part, denominator. Why are we ignoring the denominator here?
Since the denominator is all same for every other different word.
Okay.
So we ignore it.
So whatever Bilal said is correct, but nobody heard it other than me, right? So he said that because the denominator is always the same, whatever tags you choose. Okay, what is this problem? This problem is choosing the tags, right? Words are already fixed. We know the words. So why are we measuring the probability of those words? Whatever they are, it is the same thing. So what are we going to do? Just ignore the words, not ignore the words, sorry. Ignore this probability and calculate the top part. Okay? Calculating top part is going to be, for example, I know how to calculate this one. Okay, because remember somebody has marked all the words in the pen data set. Use the Engram approach. Use the Markov approach and the Markov approximation, etc. Calculate this one. How about this one? I'm going to use the same Markov approach too. Okay, so remember this one. T1 to Tn can be calculated using this. Okay, this is just an approximation. Each T depends on the previous T. That's what I am assuming. Okay, if this assumption holds, it's kind of an assumption. Okay, then it becomes a first order hidden Markov model or first order Markov model, because remember the Markov model, this V depends only on this one, okay, not this one. Second order Markov model says that you are depending on both of them, but in this case just one. First order Markov hidden Markov model. Okay, out of this is what I got, and this is what we are going to do. So I can calculate this one. How about this one though? This one says that given all the tags, okay, what are the probabilities of these words? And I am going to make this assumption again. Okay, so this is my prior. What was the name of prior? Prior again. What do we call prior? Prior is the probability of things okay. Saksıları indirin diyorlar ya. Var mı saksı dışarı?
Çevir yok mu?
Yok, saksı yok. Okay, we are safe then. We are at the top floor anyway, so.
It's a risky.
So, what is the prior probability? Prior probability is just as opposed to a posterior probability. Prior probability is probability of something that doesn't depend on anything else. We don't know anything, so this is our prior. Without knowing anything, what is the prior probability of seeing these n tags together? And this is the likelihood. Likelihood is, okay, what is the likelihood of this tag belonging to this word? Okay, and we are going to approximate this one with this one. Can you read this one? Just read this to me. What kind of approximation is this? By the way, this is n, but for some reason, while I am testing it, okay, so this is n. Let me, while you are thinking, I am trying to make a perfect n. It is perfect. So, why is this, what does it say? It says that,
A multiplication of every word with every tag.
yeah, is supposed to be equal to this one. This one says that given this tag sequence, what is the probability of observing these words? Okay, all of them at the same time. This one says that it is the same as, okay, given verb, the probability of read, given noun, the probability of book, given something, probability. So this one loses the order, okay. So this one just measures, okay, given tag, what is the probability, given verb, what is the probability of read, okay. So this one loses the sequence information, but the sequence information will come from the other part. This one has the sequence information, okay. And for the sequence information, we are going to use this Markov assumption again. This guy is biased, okay. This guy is Markov. This is British. This is Russian. I think, yeah. Is that true? And both of them are mammals. Yeah, this is okay. So this assumption we already made. Okay, this is the assumption that uses the bigrams, right? This one that uses the bigrams. A word depends only on the word before, and if I multiply them together, I get to calculate the probability of the whole sentence, and that's what I'm doing here. This time I'm using only the bigrams, and that's what I get. Okay, so what did I do now? I am talking about the sequence of the tags, and I'm talking about the probability of observation those words given the tags. Both of them, if I multiply together, I will get the final result. This is very similar to the spelling correction. With the spelling correction, our tags are the real words, our observations are the observed words, okay? So remember, I calculated this. What is the probability of the, if I write the, okay, that's what it calculates. And then the other part calculates what is the probability of having a man after the, okay? So same as the spelling correction application, but this time I am using it for the part of speech tagging. Good. Okay, two kinds of probabilities. One is this. Okay, given the previous tag, what is my next tag? And it is if you have such a marked data set, okay, it is easy to calculate it. So how do I do this? Given determiner, what is the probability of next tag being the noun? How do I do this? Okay, I count all the, okay, this is determiner and noun. Okay, I count all the determiners. Okay, how many times the determiners happened, and how many times after the determiner I have a noun. Okay, so make this division. This will give you the probability. So maximum likelihood estimation probability, and this is how I calculate it. Is this a very large probability? Is this something expected? Almost 50%.
Much higher than that.
You would expect much higher than that? Why?
What can come after a determinant that is now?
Adjective. The good man.
Right.
Yeah. You don't know English. Our problem in Turkey is that, where are you from? Russia. Okay. No, you're not Russia. You're not from Russia. Kind of Russia.
I was born in Russia.
Yeah.
Then I moved to Jordan.
So you didn't like Marco being Russian?
No.
You don't like Bias being English?
No,
Okay.
let him be English. We have one at least.
Okay. Okay. You know that our the fundamental enemies in this Russians and the English. You know that, right?
Right.
Well, historically, we had the most number of wars with Russians and the English. Okay, but we like them anyway. So this is a very good probability 50% of it. And I was talking about the why we can't learn English, because they try to teach English using these kind of statistics. They say that after the determiner there is definitely a man or something like that. We know the rules very well, but we can't speak the language for some reason. Okay, so I got this. So I can calculate this transition probabilities easily given the sentence, given these kind of sentences. That flight, the yellow hat, and okay, etc. So seeing all these kind of assignments by hand, I can calculate this using the maximum likelihood estimation. Of course, we need some kind of a smoothing, otherwise most of the sequences will produce zero probability. If the zero probabilities are there, I will be in trouble calculating this one. So we need smoothing. Without smoothing, life is not easy. But it is very easy. Everything turns out to be zero, but that will not produce anything useful. So that's one kind of probability, the transitions. The other kind of probability is, okay, we already did this. What is this? Okay, yeah, the other kind of probability is this, okay. Work likelihood probability. Given the tag, what is the probability of S? So, how many times I have seen this tag VBZ? What is VBZ? Verb simple tense, I guess. Okay. So VBZ happened 21,000 times. Okay. What was VBZ? This doesn't make sense. This is 33. Let me go back to my table.
Maybe gerund.
These are, okay. Verb, third single present tense. So this to be verb, third single present is. Okay. Let's go to 33 now. Let's go to 33 now. I had a lot of Russian friends. I always asked them, what are you going to do with the warm waters? And what do you mean? They, what are you going to do with warm waters? Because they told us in high school that Russians wanted to go to the warm waters. That's why they need to go to the strait, Bosporus Straits and etc. They didn't know about warm waters, the Russians.
What they end up doing is just moving a lot of people to Antalya, and now
Yeah,
to the point where you can go to Antalya and speak Russian.
But we invented that, okay? So Russian people didn't know that they wanted the warm water. They didn't know that. Nobody knows it. Okay. This is how we do that. VBZ. How many times VBZ happened? Okay. Out of them, okay. How many of them is, and this is a very high probability actually. Is happening almost half the time. Okay.
This is quite common.
Yeah. Well, I would expect maybe 10%. Yeah. Well, I mean, this is statistics, and it is all surprises, and this is that. So this one is likelihood. Remember this picture that I had drawn? This case, let me use the color. Okay. Pronoun, verb, okay, and noun. Okay, I read books, etc. This one is verb likelihood, okay, word likelihood. So pronoun I, and this one is read, this one is book. So here I calculate given the tag pronoun, what is the probability of observing I, word likelihood, observation likelihood. This one says that given pronoun, what is the probability that the next one will be a verb? If I multiply these two and multiply these two and multiply that one, that will give you the assignment probability for the whole sentence. And I am not doing this because it looks nice. I am doing this because I base all of my decisions using this bias formula and Markov chain and Markov assumption. Okay? And since my variables are hidden, I call this hidden Markov model. I cannot observe my variables I cannot observe my tags in the real world. In the real world, there is no pronouns. You realize this, right? There are no pronouns in the real world. We invented them. Humans invented them, right? Nobody knows. If somebody speaks Turkish without getting to the school or without looking at any books, pronoun or verb or noun doesn't make any sense for them, right? And these are the kind of the linguistic models of the language. And that model doesn't have to be correct. But since we don't have anything, we are using that one, right? For the neural language models, the language model that uses only the neural networks, you don't have any pronouns or verbs or nouns, okay? You have only characters, that's it. So I used two, three strong theories, models, and I calculated this. Now I can come up with a sort of tags that will make the multiplication of these observations and sequence transitions maximum, and that will be it. Okay, let's go back to this example. Secretariat is expected to raise tomorrow. Okay, there are two ways of making this assignment. Okay, either this one or this one. Oh, sorry. Either this one, Secretariat is expected to raise verb tomorrow, or to raise noun tomorrow. Okay, let's see which one is going to be the correct one. Okay, so this is verb, this is noun. Okay, so we simplify the problem. Okay, I am sorry for the. Let me hide this because I cannot erase them. Let me hide this. Let me, if I can, annotations. Yeah, flatten, import, don't show annotations. Good. So, what is the difference between A and B? Raise.
Raise is verb and
Yeah.
B is noun.
Simplify the problem. Of course, there are other ambiguities, but I am just using the most prominent one. Okay, so either verb raise or the noun raise. So it looks like, remember I am going to do this. I will calculate this probability, transition, and this observation probability. But between this, the transition probability is here and there, and they are all the same. The only different things are this transition probability here are different, right? This one is different, and this one and this one. So the ones that are marked with the thicker arrows is the ones that I am going to look at. The rest of them is the same. So I will multiply these three numbers, and I will multiply these three numbers, okay, and compare them. Which one is higher? I will choose that one. Okay, so let me show it. Okay, good. So this one is given to, what is the probability of noun previously? Given noun, what is the probability of NR? What is NR? Adverb? Yeah, adverb. And this one. Okay, if we do that, this is what the book is doing. Okay, this one is 2NN and 2VB. Oh, look at this one. 2NN is not 0. Given to, the probability of NN is not 0. By the way, this is not a proposition 2. Okay, it's a 2. Remember, 2 has itself its own tag. Okay, so even with this case, there is still a probability of 0.00047. Okay, so this one is high. This is, again, race is usually used as a noun. That's what it says, right?
Yeah, but
Yeah, it is like 5 times more. Right? It is 5 times more probability, but the other hand, the sequence information is after 2 I get a verb 80% of the time. Okay? And after that, these are kind of comparable. After noun, there is an adjective probability. After verb, there is a adverb probability. It's kind of the same. If I multiply these two and put them together, it looks like this one is way higher than 10,000 times. How many times, I don't know.
I mean, the NN2 and the VB2, they're like, they have 3 orders of magnitude
Yeah.
difference.
So it makes up the difference and more than that. So we say that we choose the verb reading. Race has to be, well, most probably, okay, 1,000 times more probable that race is a verb here, not noun. Okay? So that's the beauty of using these kind of probabilistic models. They never say no. Okay, they never say no, it cannot happen. They say, well, there is a chance, but it is this much. Okay, it is this much. So this is most probably a verb. Okay, good. Any questions so far? Well, I mean, I simplified things. What did I say? Well, I mean, this is ambiguous. This one is expected. It could be a noun, right? It could be a adjective too. Tomorrow, it could be a noun, an adjective, an adverb, and etc. So I ignored all of them. I already said that this is ambiguous. If you put all of them together, what am I going to do? I will do, let's say for each one there are 3 possibilities. 3 to the power 6 is going to be bad, okay? 3 to the power 6 is a very large number, and this is not a very normal looking sentence, very simple sentence, okay? So we have to find a way of doing these calculations in a more efficient way. In this case, again, we can use the dynamic programming. Why? Because my dependencies are, again, for the previous word. Okay? What did we say? We said that this is my background probability given to the probability of NN. We are not doing anything more than that. Okay? So I am only dependent on the previous tag due to my assumption. In this case, I can run a dynamic programming approach, and that will be my solution. So it will be both correct in terms of our assumptions, Markov assumption, hidden Markov model, Bayesian rule, okay? And I will find a dynamic programming or principle optimality based solution to the calculation of the correct tags, and I will give you a very nice solution, okay? So that's what we are going to do in a few minutes. Okay. But before that, I think I am going to give you the formal definition of the hidden Markov model, okay? It's just a weighted finite state automaton, okay? Markov chain. This is Markov chain part. This part is Markov chain part. State, and state. Let's ignore the observations for now, okay? And there is a transition probability between these. Okay, there is a transition probability between those. Okay, so let's look at this one. This is a first order Markov chain, Markov model, but it is not a hidden Markov model. It's an observable Markov model. Okay, all transitions. It will give me the probabilities of having a, for example, cold, hot, rainy, hot, rainy, cold days one after the other. Okay, for example, for the June season of the Gebze area. Okay, So what kind of transitions I have at the beginning of the transitions? Given any day, what would be the possibility of it being cold or hot or rainy? Okay, that's the start of it. And then after a hot day, what is the possibility of having a rainy day, or having a cold day, or having another hot day? These are the transition probabilities. Okay, this is not hidden Markov model. Why? Because my observations are my states. Everything is visible, right? Everything is visible. So I have only one probability set, transition probability. So this one A01 means that probability of going from 0 to 1. This is A02, probability of going 0 to 2, and A03. So as you have expected, the sum of these three numbers is 1.0, right? 1.0. Also, sum of this number, can I do that? Let me do it for this 3. Sum of this number, and this number again 1.0, right? Because something has to happen there. Okay, so this is observable Markov model, not hidden Markov model. Observable Markov model of order 1, first order. Why is it first order?
So only choose one.
Only one state.
Yeah, we are looking at only one state before. Okay, if I am looking at if I am dependent on what happened in 2 days before, I am not going to say yesterday was hot. What is the probability of being a hot day? Yeah, that's the first order. But if somebody tells me that last 2 days were hot, and hot, what is the probability of today being hot? That's the second Markov order. Of course, second order Markov chain is better than the first order, but getting the statistics and doing all those calculations is difficult for the second order or third order ones. That's why we like the first order Markov chains a lot. Okay. Again, this is observable Markov model, not hidden. Observable Markov model. When we say that I don't have an observation about being hot or cold, all I have is the number of ice cream bars that I have eaten, then in that case it becomes hidden Markov model. Okay, I think I'm going to stop here. Next week I will finish up with this chapter and we will start talking about parsing, which is one level up. We will talk about the whole sentences now. Okay, are there any questions? Did everybody sign the attendance sheet? Okay, thank you. I'll see you. So, dikkat edin ağaçlara. Saksılara da dikkat edin.